Now at times you'll be given a function in terms of parameters. Say x as some function of t and y as some function of parameter t. Now here we have to check differentiability of this parametric function. Now we know that dy by dx is dy by dt upon dx by dt. Now to check for the differentiability of dy by dx, we have to check differentiability of these individual parts, and we can write this as this limit delta t tends to 0, and it will be g t plus delta t minus gt upon delta t divided by dx upon dt, which is f t plus delta t minus ft upon delta t. So basically we have to find this limit, which is limit delta t tends to 0, and it will be this g t plus delta t minus gt upon f t plus delta t minus ft. Now we can check both left hand derivative and right hand derivative for t using delta t as 0 plus h and 0 minus h. So if we write its left hand derivative will be this limit h tends to 0 g t minus h minus gt upon f t minus h minus ft, and we can write its right hand derivative as this limit h tends to 0 g t plus h minus gt upon f t plus h minus ft. Now let us take one example. Say for example, we are given this function which is y equals 2t square minus t into mod t and x equals 2t minus mod of t minus 1 for all t belongs to R where t is a parameter. Now we have to find differentiability of y equals fx at x equals 2. Now we know this y is a function of t, and here we have polynomial and modulus functions, so it is continuous in t belongs to R, and here also this x is continuous in t belongs to R. So when we are going to write this function fx, it will be continuous in t belongs to R. So this function y equals fx will be continuous, so we just have to check differentiability at x equals 2. Now in order to check differentiability at x equal to 2, first we'll find the value of t. So if we put x as 2, we'll write 2t minus mod of t minus 1, it is equal to 2, or we can write 2 t minus 1, it is equal to mod of t minus 1. Now if t is unequal to 1, we'll get 2 equals 1 or minus 1, which is not true. So from here, the only solution we'll get is t equals 1. So we have to check differentiability of this function when the value of t is 1. Now first we'll check its left hand derivative. Now its left hand derivative will be f dash 1 negative, and will be this limit h tends to 0, and will be this y 1 minus h minus y1 upon x 1 minus h minus x1. Now this is this limit h tends to 0. Now y is this value, so it will be this 2 and then 1 minus h whole square minus 1 minus h and then mod of 1 minus h minus y1, and when t is 1, value of y is 1, so it will be this minus 1 upon, now x1 minus h will be 2 1 minus h minus mod of 1 minus h minus 1 and then minus, now when t is 1, value of x is 2, so it will be this value 2. Now, when h is 0, mod of 1 minus h will be simply 1 minus h. And here, mod of minus h will be simply h. So we can write this as this limit h tends to 0. This is 2, 1 minus h square, and then minus 1 minus h square minus 1 upon 2 into 1 minus h minus 2. And we simplify this, we'll get this as this limit h tends to 0. Now this is 1 minus h square, which is 1 plus h square minus 2h minus 1. And here this 2 and 2 will cancel, and we'll get this as minus 3h. So this 1 and 1 will cancel. So here value of this limit will be coefficient of h, and which is 2 by 3. So its left hand derivative is simply 2 by 3. Now we'll find its right hand derivative. Now, right hand derivative of this function at 1, it will be this limit h tends to 0 y 1 plus h minus y1 upon x 1 plus h minus x1. Now it will be this limit h tends to 0, and here it will be 2 1 plus h whole square minus 1 plus h into mod of 1 plus h minus y1, and y1 is 1 upon, now x1 plus h is 2 times 1 plus h minus mod of 1 plus h minus 1, and then minus x1, and x1 is 2. Now this is limit h tends to 0. Now 1 plus h is greater than 0, and h is also greater than 0. So it will be 1 plus h whole square. So we can write this as 1 plus h square minus 1 upon, now this 2 and 2 will cancel, and here it will be this h. So we can write this as this limit h tends to 0, h square plus 2h upon h, and value of this limit will be 2. So here left hand derivative is 2 by 3 and right hand derivative is 2. So this function is not differentiable at x equals 2. Now another way to solve the same problem is using the function definition directly. Now we know that we have to check differentiability at t equals 1. Now at t equals 1, this definition mod t will be simply plus t. So in the neighborhood of t equals 1, this function y, it will be simply 2t square minus t square, which is simply t square. Whereas this x will take two different forms. When t is less than 1, this value t minus 1 will be negative. So we'll get this as 2t plus t minus 1. And when t is greater than or equal to 1, this value will be positive. So then it will be 2t minus t plus 1. So this x, it will be 3t minus 1 when t is less than 1, and it will be t plus 1 when t is greater than or equal to 1. So in the neighborhood of t equals 1, we'll have two definitions. First definition is in the left neighborhood of t, which is 1 negative. Now here x is 3t minus 1. So we can write t as x plus 1 by 3, and y is simply t square. So we'll get y as x plus 1 by 2 whole square by 9. And for right neighborhood, that is t tends to 1 positive, definition is t plus 1, we can write t as x minus 1. So here y, it will be x minus 1 whole square. So basically we can write this function fx as x plus 1 whole square by 9 in the left neighborhood of 2, and it is x minus 1 whole square in the right neighborhood of 2. Now, if we check its continuity, we'll simply put the value. Now here this value will be 2 plus 1, 3. So f 2 negative, it will be 3 square 9 by 9, which is 1. And f 2 positive, it will be 2 minus 1, 1. And f2 is also 1. So this function is continuous at x equal to 2. And if we find f dash x, we'll get this as 2x plus 1 by 9 when x tends to 2 negative. It is 2x minus 1 when x tends to 2 positive. Now if we put the value of x as 2, we'll get left hand derivative as 2 into 3 by 9, which is 2 by 3, and its right hand derivative as f dash 2 positive, and it will be this 2 into 1, which is 2. So here again we get the same result, that this function is continuous but not differentiable at x equals 2.